Howdy and welcome to Advent of Code 2022. I'm John Eisen. I'm just trying to get these done by the end of the year after the competition has ended. And so today we're going to do day 21. So let's get started. Let me switch the scene. And we're ready to go. Monkey math. The monkeys are back. You're worried they're going to try and steal your stuff again, but it seems like they're just holding their ground and making various monkey noises at you. Eventually, one of the elephants realizes you don't speak monkey and comes over to interpret. As it turns out, they overheard you talking about trying to find the grove, and they can show you a shortcut if you answer their riddle. Each monkey is given a job either to yell a specific number or yell the result of a math operation. All of the number yelling monkeys know their number from the start. However, the math operation monkeys need to wait for two other monkeys to yell a number, and those two other monkeys might also be waiting on other monkeys. Okay. Your job is to work out the number of monkey named Root. Work out the number the monkey named Root will yell before the monkeys figure it out themselves. All right, so Root is PP. All right, so you're just solving this? That seems doable. Is it recursive, though? It can't be recursive. This is like a directed acyclic graph, right? So you start with or you can start with root, and root points to PP and SJ, and then PP points to CC and LF, and CC points to SL and LG, and SL is like just a node. And then so what do we have to determine? You're actually considered, so what number, so we just need to know what number Root will yell. So we just need to calculate it. But I bet part 2 asks us to calculate when he says it. So, but let's not worry about that for now. Just grab these inputs. 2,200 lines. Okay. It's not too bad. Okay. So let's start with just reading our inputs. Let's create a data class for each monkey. And each monkey has a name and either an operation or a number. So literal, optional, int, or operation, optional, tuple of, we'll call it an operation, which would be a name tuple, class, operation, named tuple, and that will be a left stir, a right stir, and an operation, an op type, we'll call it an op type, right? And then we'll do class op type, which is an enum.enum, and this is either plus minus time multiplication equals times, and division equals, we'll call this subtraction and addition. Nice. 1, 2, 3, sweet. All right, and then we just gotta do parsings, right? So at static method def parse raw stir to operation return, so we split, so left op type right equals raw.split on space, and you guys should be pretty familiar with this, so then we just return operation left, right, and we cast to op type the op type. Nice, that all works. And then class monkey needs a static method, def parse raw stir to monkey, and we do name statement equals raw.split on, this time would be colon space, and if statement, well, let's try, we'll just do try, we'll use the Pythonic way, return monkey name equals name, literal equals int statement operation equals none, except return monkey name equals name, literal equals none, operation equals operation dot parse statement. All right, so what we're going to do is basically cast the statement to an int. If it is an integer, it will pass. If it is not, it will throw an exception, in which case we will determine that it's an operation, and we will return the operation.parse of that statement. And that is how we'll do the monkey. Nice. And then we just need monkeys, which is a list of monkey. And we just do monkey.parse on the line. Yep, and we can just print input dot monkeys here, go to day 21, clear our Python, day 21 example, and yes, we have a bunch of monkeys, and we have a root and all that. All right, cool. So how do we want to solve this problem? One way we can do it is change our list of monkeys into a map of monkeys, and then just recursively calculate it. Yeah, I mean, I think that's pretty easy. So monkey map equals monkey.name to monkey for monkey in input.monkeys. Nice. And then def calculate monkey. We'll put this on monkey, right? Nah, we'll put it here. All right. If monkey.literal return monkey.literal, else return op equals monkey.operation, left equals calc monkey op.left, do the same thing for right, and then return op type monkey op type dot evaluate left right. Okay, and then we just return calc monkey map root, and that should do that. The only thing we have to add is this op type, so def evaluate self left right. And this is just a switch statement, so if self equals op type dot addition, turn left plus right, elif self equals op type dot subtraction, left minus right, and this is multiplication, This is division. Nice. Okay, so we're ready to run it. 152. Nice. We can intcast this so we don't get float stuff, and then input. Ready to go. Nice. Good job. We just implemented the problem. I think part 2 is going to be significantly harder. Due to some kind of monkey elephant human mistranslation, you have misunderstood a few key details. First, you get the wrong job for the monkey named root. Specifically, you got the wrong math operation. The correct operation for the monkey root should be equals, which means that it still listens for 2 numbers, but now checks that the 2 numbers match. Second, you got the wrong monkey for the job starting with human. It isn't a monkey, it's you. Actually, you got the job wrong too. You need to figure out what number you need to yell so that root's equality check passes. It appears after human in your input is irrelevant. Okay. All right. So now we have to do reverse stuff here. All right. So I'm going to scroll up to this equality. So that means human, anytime human is in here, we need to calculate what human's value needs to be, right? So root is an equality check between these 2 values. So one of them contains human and one does not. So, all right. So the first thing I want to do is know which value we can calculate. So without knowing human. So what I'm going to do is here. We're gonna do this calculation, but the first thing we're gonna do is check if monkey.name is equal to human, then raise an exception. Human found. And so root left is going to be, I'm going to do calc monkey map root. Well, we'll do root equals monkey map root. And then we're going to take that root and calculate its left value. All right, so or target, we're going to do try, move this to the center, and we're going to do target is calculate root dot operation dot left monkey map. Nice. Okay. And if that fails, oh, and then so the target value and the monkey name. What do I want to call it? I want to call which one of these monkeys we have to calculate. So then we'll just call it algebra name equals root.operation.right. So if we can calculate root.operation.left, then we know that it comes out to a literal value. But if it throws the human found operation, then we know it's the other way around. So we do except target value equals calc monkey map root.operation.right, and we do alg name equals root.operation.left. All right, so that will get us where we're starting, which will be, okay, so say PPBW, what is it? What is this? So say PPBW can be calculated and it comes out to some value. Then SJMN must contain human, so it needs to be evaluated. And so what we want to do is then recursively invert each operation. And we're actually going to have to recursively do something like this. So while alg name does not equal human, we need to invert the whatever alg name is. So monkey equals monkey map alg name. So then we're going to get a monkey. So let's say PPW we know is 100. And we know SJMN must be 100. So then we look at SJMN and we invert these operations. So first thing we do is we do the same operation that we figure out which one can be calculated. And instead of doing root, we do monkey. And it has to be an operation here. If it's not an operation, that doesn't make any sense because we're going down to find humans. So assert monkey, monkey dot literal is none. Okay. So then we have to invert. So then we do target value equals invert equals monkey dot operation dot op type dot invert. And so in this case, left can be calculated. So we do left equals sub-target value, outcome equals target value. And this will invert to the right. And we have to go write this function, of course, but we can do this. So this will just invert the mathematical operation. In this case, it'll be right. And then, nice. Okay, all right, so now we just have to write this invert function that can take a left or a right. Def invert self left equals none, right equals none, outcome equals none. And so if left is given, so is not none. Remember, we had some zero bugs earlier in this advent. Then we just go through and so if left is not none, well, first of all, it doesn't matter if, If less is not none, then we're going to go through each. We can probably do this a little faster, but let me first start by doing this. So if it's addition, then we just do outcome minus left, right? And if it's subtraction, we do negative. So if it's subtraction and we have left, then we want negative outcome minus left. So we do outcome minus left. If it's multiplication, we do outcome divided by left. And division, we do, if it's division and we have left, then we do left divided by outcome. Yeah. If you don't get that, then it's just some basic algebra. Sorry to be condescending. essentially, if you have left and you were searching for the right-hand side, you multiply both sides by the right-hand side. So you get LFQF times PPW equals CZZH. Then you divide both sides by PPW, and you get LFQF equals CZZH divided by PPW, which in this case is left divided by outcome. So there we go. And then we do the same thing for the right, which we just assume is else. And the op type, if its addition, is outcome minus right, and the same thing for multiplication. Now with subtraction, if we have the right, but we're searching for the left, we just need to add this to both sides. So this is plus. And for division, if we have the right-hand side but are looking for the left, we just multiply both sides by LFQF, so we get times. Nice. Okay. Cool. So I think we're ready to run it. I think that should be good. We get 301, which is the answer. So we're going to do it on the input. Nice. We got it right. That one was relatively easy for me just because, I don't know. I just kind of got it really quickly, I guess. And I understand some of the inverting algebra pretty quickly. Do have 2 math degrees, so that go figure. But hope you guys enjoyed that one. That one was really fun. I like when they're complex but fast. So yeah, hope you guys enjoyed. See you next time.